All right, welcome students. We're going to continue with word problems today. Today we're going to look at geometry problems, and specifically we're going to focus on perimeter. So we need to define the perimeter of a two-dimensional shape. The perimeter of a two-dimensional shape is the total distance around its edges. Now today we're going to be focusing on rectangles, so let me give you a rectangle. And a rectangle is a shape, a two-dimensional shape, that has four right angles, four 90-degree angles. Okay, if you haven't seen a right angle or a 90-degree angle defined before, it's basically the angle that you get on the corner of a regular sheet of paper. All right, so this is our rectangle. We can label the sides length and width. And one fact about rectangles is that opposite sides are the same. So if the bottom has length L, the top is also going to have length L. And if one side has width W, the other side is going to have width W. Now we're told the perimeter is the total distance around its edges. So what we do is we start in this corner and we add up all the different distances as we go around to get the perimeter. So the perimeter is the length plus the width plus another length plus another width. We get that by starting in this corner, and as we walk around the outside, we go L, and then we move W, and then we go another L, and then we move another W. So we get P equals L plus W plus L plus W. We can write this more simply by combining like terms. L plus L is 2L, and W plus W is 2W. So we have P equals 2L plus 2W, and this is the formula for the perimeter of a rectangle. We're going to be using this whenever we do word problems involving perimeters of rectangles. We're going to do one problem in this video, and then you can look at as many more as you like in the videos linked below. Now, let's take a look at our first problem. In the NBA, each basketball court has a length that is 6 feet less than twice the width. The perimeter of each court is 288 feet. Find the dimensions of the court. This is a very typical perimeter problem. We've read the problem. We need to write our let statements, so we need to figure out what they're asking us to find. Here they're asking us to find the dimensions of the court. Now we need to have a discussion about dimensions. When we're asked for the dimensions, what that means is the length and the width. If we're looking at a rectangle that has a length and a width, if we're looking at something that's hung up on the wall like a picture, we might have height and width. We might actually have length and height. There's different possibilities here depending on the words that we're using, but in general, when we're asked for the dimensions, we want to know what is the length, what is the width, what is the height. Any distance that is named in general is a dimension. When we're dealing with rectangles, it's a two-dimensional object, so we're going to have two dimensions, length and width, height and width, length and height. If we were talking about maybe a box in 3 dimensions, those 3 dimensions would be length, width, and height. Hopefully you understand. The biggest mistake that students make when they don't understand this is they write, let the dimensions be X. And that shows me that they really don't understand what's going on. So please ask questions if you have them. I am happy to help you understand this. In this problem, we're asked for the dimensions, and those dimensions are going to be length and width, so we need to write let statements for both of those. Let the length be something, and let the width be something. Now we need to figure out which of these is x. We're told it has a length that is 6 feet less than twice the width. Because we're told something about the length based on the width, that means the width is going to be x. Now we need to figure out what the length is going to be. The problem says the length is 6 feet less than twice the width. Now, there's two different ways that students attempt to express this. One of them is right and one of them is wrong. 6 feet less than twice the width is either going to be 6 minus 2x or 2x minus 6. And my question for you is, which of these is correct? And usually about half the students get it right and half the students get it wrong. I'm going to give you the answer. The correct answer is going to be 2x minus 6, not 6 minus 2x. The reason is, when it says 6 feet less than something, that means 6 is getting subtracted from something else. So that's going to be 2x minus 6. Twice the width is represented by 2x, and 6 feet less than that means we're subtracting 6 from it, so it's going to end up being 2x minus 6. With subtraction, the order matters, so you've got to make sure you're interpreting this correctly. Now we have expressions for the length and the width. We need to write an equation that models this situation. The piece of information we haven't used yet is the perimeter, which is 288 feet. Whenever we're dealing with the perimeter of a rectangle, we use the formula for perimeter. So we're going to use P equals 2L plus 2W. This is the formula that's going to help us finish this problem, but what we need to do is we need to substitute in for the perimeter, the length, and the width to turn it into an equation that we can solve. The perimeter, we're told, is 288, so we plug that in there, equals 2 times the length. Well, the length is 2x minus 6, plus 2 times the width. We said the width is x. By plugging in all of these quantities, we've gone from a formula with multiple variables to an equation that just has x in it. So now we can solve for x. On the right-hand side, we need to distribute this 2. 2 times 2x is 4x, minus 2 times 6 is 12. And then plus 2 times x gives us 2x. We combine like terms on the right-hand side. 4x plus 2x is 6x. So we've got 6x minus 12 on the right. To get rid of this 12, we need to add 12 to both sides. 288 plus 12 is 300, and that leaves us with 6x on the right. To get x alone, we divide both sides by 6, and that gives us 50 equals x. Now we go back to our let statements. The width was x, which we know now is 50, and that's measured in feet. The length is 2x minus 6. 2 times 50 is 100, minus 6 is 94. So that's going to be 94 feet. Now they asked us for the dimensions, so our final conclusion will be the length is 94 feet and the width is 50 feet. And that is our final answer.